Imagine a world cloaked in darkness, a world where the setting sun brought an end to most human activity, where the only light came from fire, a flickering candle, a smoky oil lamp. For most of human history, this was our reality. But all along, an invisible force was waiting to be discovered, a force that would one day banish the darkness and reshape civilization itself. This is the story of that force. Our journey begins long ago, over 2 millennia in the past, in ancient Greece. The Greeks were keen observers of the natural world. They rubbed a piece of amber, electron, against fur. The amber gained a strange new property. It could attract light objects, feathers, bits of straw, making them leap through the air as if by magic. They couldn't explain it. A mere curiosity, a parlor trick. But humanity had its first fleeting encounter with static electricity. A tiny spark. A whisper of immense power. For centuries it remained a mystery. A footnote in dusty texts. The world turned, powered by muscle, wind, water. Electron lay dormant, waiting for the right minds. The universe is patient. Knowledge encoded in physics waited for curious minds. The spark of curiosity, like static on amber, never truly dies. Fast forward to the 18th century. The world is buzzing with new ideas. In the American colonies, a man named Benjamin Franklin, a printer, a writer, a boundless thinker, turned his gaze to the sky. He looked at the terrifying, awesome power of a thunderstorm. He saw the jagged bolts of lightning that split the heavens, and wondered, could this celestial fire be the same force that made feathers jump to a piece of amber? He suspected they were one and the same. To prove it, he devised one of the most famous and dangerous experiments in the history of science. A child's kite, a metal key, a stormy night. You know the story. Franklin flew his kite into a thundercloud. He wasn't trying to get struck by lightning. That would have been fatal. He was trying to collect the ambient electrical charge from the storm clouds. As the storm raged, he noticed the loose threads on his hemp kite string stand on end. He brought his knuckle close to the metal key tied to the string and, zap! A spark jumped. It was the same kind of spark he could create by rubbing glass, but magnified on a cosmic scale. Franklin had proven it. Lightning was electricity, but the sparks they could create in the lab were fleeting. They lasted for only an instant. The solution came from Italy, from a physicist named Alessandro Volta. He created a stack, a pile of alternating disks of 2 different metals, separated by cardboard soaked in salt water. When he connected a wire to the top and bottom of this pile, a steady, continuous electric current began to flow. He had invented the first battery, the voltaic pile. For the first time, humanity had a reliable, portable source of electricity on demand. And no one used it more brilliantly than a self-taught English scientist named Michael Faraday. Faraday was a bookbinder's apprentice with an insatiable curiosity. He saw the world in terms of invisible forces, lines of energy flowing through space. He had a hunch: electricity and magnetism were 2 sides of the same coin. He demonstrated that an electric current could create a magnetic field. But could it work the other way? Could a magnet create electricity? For years, Faraday toiled in his laboratory at the Royal Institution in London. He tried countless arrangements of wires. Then, in 1831, he found it. He moved a magnet through a coil of copper wire. A momentary electric current appeared in the wire. It was subtle, but the implications were monumental. By spinning a magnet near a wire, he could generate a continuous flow of electricity. This was the principle behind the electric generator. Faraday gave us the ability to generate electricity. But how to use it? Enter Thomas Edison. Edison ran a massive invention factory in Menlo Park, New Jersey. His goal? Build a system to bring electric light into every home. Replace dirty, dangerous, dim gas lamps and candles. His most famous quest was a practical, long-lasting light bulb. He and his team tested thousands of filament materials. They tried platinum. They tried bamboo fiber. Finally, carbonized cotton thread that glowed for hours. On New Year's Eve, 1879, Edison lit the streets around his lab. A spectacle. Crowds awestruck by steady, brilliant light. But the bulb was one piece. Edison developed generators. Edison developed the wiring. Edison developed the sockets. Edison developed the switches. The age of light had begun. Edison's vision was grand, but it was just the beginning. The world was about to be completely rewired, and the process was driven by a fierce competition of ideas. Edison's system used direct current, or DC, where electricity flows in one direction. It worked well over short distances, but was inefficient for sending power far away. Another brilliant mind, Nikola Tesla, championed a different approach: alternating current, or AC. In an AC system, the current rapidly reverses its direction, which allows voltages to be easily stepped up and down using transformers. This made it possible to transmit electricity efficiently over hundreds of miles. The war of the currents was on. Ultimately, the flexibility and efficiency of Tesla's AC system won out for long-distance power transmission. This victory paved the way for the creation of massive power grids. Giant hydroelectric dams, like the one at Niagara Falls, could now harness the immense power of nature and send it to cities far away. Power plants, burning coal or gas, could be built outside of urban centers, feeding electricity into a vast network that stretched across the country like a mechanical nervous system. This new energy source transformed every aspect of life. At home, the change was revolutionary. The night was no longer a barrier. Homes filled with clean, bright electric light, making them safer and extending the day for work, study, and leisure. But it went far beyond lighting. A host of new appliances appeared, promising to end domestic drudgery. Factories, too, were reborn in the electric age. Before electricity, factories were a chaotic mess of belts and pulleys, all powered by a single, massive steam engine. Electric motors changed everything. Now each machine could have its own individual motor. This led to mass production on a scale never before imagined, creating new industries and reshaping the global economy. Look around you, right now. The device you are using to read these words is a marvel of electrical engineering. We have woven electricity so deeply into the fabric of our lives that we barely notice it anymore. It has become as essential as air and water. As we confront the great challenges of the 21st century, from climate change to resource scarcity, our relationship with electricity must evolve once again. The future is, and must be,